am Assistant Professor in CSE Department in PSN College of Engineering and Technology. Today we are going to discuss about what are the basic concepts available in data structures. Then here, what is data structures? Why we have to go for the data structures? Normally, the data structure means a way of organizing data, not only the item stored but also their relationship to each other. Then what are the different kinds of data structures? Linear data structure and then is the non-linear data structures. Linear data structure means what? All the data items can be arranged in a sequential manner. For example, the array and then linked list and then stack, queue, etc. And then non-linear data structure means what? Is the elements are arranged in not in a sequential ladder. Is a tree, graph is an example for the which one non-linear data structures. So we got to set it. What are the application of the data structures? Where it is used? Normally in the computer science and the database and then algorithms and also even software development. All the fields we have to use in this data structure because we have to make our code as the efficient one. Because it is the main application. We have to make our code as the efficient and also the code can be easy to understand. Then only we can able to develop our software as easy. Another thing is the list. The list means what? We have to ordering the set of the elements L1, L2, L3 up to Ln. We got to write it. We got to set it the form of means was A1, A2 up to the An. A1 means is the first element. All others are the middle element. The following finally we say An is the last elements. Then is the size of the array. And what are the list operations can be performed? So insert, delete, find, next, previous, print list, and make empty. Okay, they all operations can be all operations can be performed by using this list. Another thing is the singly linked list. So normally the singly linked list means what? One node is connected to the next node by means of using this a single linked list. So basically the node means what consists of one is the node, another thing is the next pointing node is a link field. Okay, the link field can be pointing the address of the next node. So data field what we have to store in the values. Okay, so for example, in our example 10, 20, 30, 40, these all are the data. Data means was the values. Then we got to put in as a arrow mode. The arrow means was is a first field, first node. The arrow mark can be pointing to the 20. Then second node, the arrow mark can be pointing to the 30. Then third node can be pointing to the 40. Then last node can be pointing as a null. Okay, this we got right. But data means what? We got to storing the list of elements. Next means what? The address of the next node in the list can be stored. Another thing is the doubly linked list. So in a single linked list, what is the only one directions can be the data can be flowed. But in the doubly linked list, the data can be flow in the two ways. So generally the data can be several means what? The first one is the previous data can be a node can be addressed. The next means was the next node can be addressed. This way we got to representing the data. First node is the data field, another thing is the preceding node, the linked list, another thing is the next node linked list. This we got to represent it. It's a two-way linked list. Okay, that is your forward directions and then reverse direction. Both the directions the data can be traversed. It's your doubly linked list. Okay, this way got represent. So A, then B, then C and D. And then you got a null. Then again what? It's a reversing order. It's a backward directions. D to C and B to B and then B to A. This way we got right. Then last thing is the null node. Now okay, we got writing as the null node means what there the symbols like this we got right. Otherwise what you got to make it the pointing field as a NULL null. This way you got to represent it. This is what the doubly linked list. Another thing is the stack. So normally the ADT means what is the abstract data type because your coding may be as the efficient one means we have to using this abstract data types. So you got to take the stack. ADT means what is a linear data structures. It can be first in first out, first in last in first out. Okay, so first in first out is the queue. Okay, last in first out is the stack. So you got writing, but that means what is the insertion and deletions. Both are performing at the one end. That end is called as the top. The insertion end is called as the push operation and then deletion operation is called as the pop operation. This way got it done because many applications we got using this stack. Okay, for evaluating an expressions or priority queues. Okay, this way so many applications we got using this stack. This is stack in the push operation means The process of inserting the new element to the top of the stack unit is referred as the push operation. For each push operation, the top is incremented by 1. Okay, for example, here just you got to see that initially the top values can be represented by -1. Then whenever you got to inserting the 10, so that time the top can be pointing to the 1. The next one, the top can be pointing to 2. Okay, likewise the values to be varied. Okay, it is in the incremental order. Okay, during our push operation, the top value can be incremented by 1. And your pop operation means what? The process of the deleting an element from the stack. That is called as a pop operation. Here the every pop operation versus this is decremented by 1 because we have already told that in our push operation the top values can be incremented by 1, but in your pop operation it can be decremented by 1. Just you got to see the diagram. The stack is initially is a full. This is a 25, 17, 8. This is the data can be stored. So whenever you are doing the pop operation, so that time the top of the elements can be removed first, because Allah we know that the stack means what? This is a last in first out. So that time which values can be lastly inserted, that values to be first deleted. So here what is, which one is the top of the item? This is 8. So the 8 can be deleted first. Next the pointer can be moved into the downward direction. This is the top, which one decremented by 1, then it becomes a 17. The top can be pointed by 17. Next we got to doing the pop operation means what? The 17 also to be deleted and the top is decremented by 1. Now you got to finding as 25. Then you got to deleting the 25 means what? After the top is values can be as -1. So this you got to referring. This is your stack pop operation. So what are the things can be studied in your stack means what? It is your push operation and then pop operation. Push means is inserting an element. Pop means what? Is deleting an element. Okay, from the stack. So this way, right? Then how to writing the notations. So normally we have to say that one of the application of this stack is what? Is evaluating an expressions. So before evaluating an expression, we must know how to notate your data. For example, normally we got to writing the data means what is infix notation. Infix notation means what? The two operands in between the operators can be placed. For example, a plus b. That means what? A is one operand, b is another operand. Then operators can be placed in between a and b. Okay, that is the infix notations. Suppose the operators can be placed before the two operands means what? That is called as the prefix notation or the polish notation. Okay, just you see the examples. This is a bar b. That means for a slash b. That means slash can be right first. After that a and b can be right. Okay, then it can be after evaluating the slash ab, we have to consist of slash ab then plus c. So that time the plus can be coming to the front. Now you got to getting plus slash ab, then you got to writing the another operand, that's value is c. So this way you got to performing at your prefix notations. Another thing is a postfix notation. It is a reverse of your polish notations. So you got referring this is a reverse polish notations. How to write? So in your prefix notation, first of all, the operand can be placed. The operators can be placed, then only the operands can be placed. But here what? First we got writing the two operands, then only we got placing as the operators. Okay, just you got see that is a slash b. That means what? A b slash. This you got write. And then plus c means what? Then c what to write? After that the plus c plus can be placed. Okay, likewise we got to doing. This is your the different notations. Okay, another thing is the QADT. QADT means what? The stack ADT, what will you do that? It is a last in first out. The queue means it's a first in first out. For example, you are in the queue for taking the ticket from any of the reservation counter or anything means what? So that who is coming to the first? That person can be taking the ticket as first. This is a first in first out. Okay. So is the queue means what? Queue is also the one of the linear data structures. Here the insertions can be performing at the rear end and deletions can be performing at the front end. Okay, so 2 pointers can be used. In stack what will you do that? Only one point can be used. That point is called as the top. But in Q, what will you do that? Here the 2 point can be used. The insertion at one end, that is called as rear, and deletion is another end, that is called as the front. Okay, here we got using the QADD. Here the insertion operation is we got referring as NQ. Okay, then the deletion operations can be referred as the DQ. Okay, this way got right. So two types of the operations can be performing with the help of the Q. Okay, what's NQ is inserting an element in a queue. Then what's DQ means what? Deleting an element from the queue. Okay, another thing is a periodic queue. Periodic means what? We got to inserting the item or removing item. We got to perform them based on some periodicity. Okay, any position we got to inserting it, but depends upon the periodicity. We got the insertion and deletions can be performing. That is referred as a periodic queue. Okay, so where it is the queue can be used means what? Some batch processing we have to use. Also, we got to sorting the elements using the keep sort means we got to use, then simulation, then queuing theory, and computer networks. Okay, so this way the many fields we got to using is this queue. Another thing is the graph. So normally here we got to study this arrays and then list and then queue and then stack. So all are this is an order. Linear data structures, but the graph and tree, they both are we got to using as non-linear data structure. Okay, linear means you know that. So and all the data can be arranging in an order. Okay, the elements are listed in an order, sequential manner. So that is called as the linear DS. Okay, but in your non-linear DS means it is not an arranging in an order. Okay, so first we got to study of the graph. In graph we got the graph G is equal to the number of vertices comma edges. It's a V comma E. V for vertices, E for this is a edges. So ordered pair of the finite sets is a V and E. The elements of V is called as the vertices, and we got to referring this as a node or points. Also the elements of V's are called as the edges. This is referred as arc or lines. Then each edge joining the two different vertices, it is can be denoting as the tuple of I comma j. Okay, where the I comma j means was the two vertices, it can be joined by with the help of the edge. Here we got to look at here. This is the two types of the graph. One is the undirected graph, another is the directed graph. Undirected means graph means what? The data can be traveled back and forth. Okay, 1 to 2 or 2 to 1, 1 to 4 or 4 to 1, then 1 to 3 or 3 to 1. Any directions it can be the data to be moved. But in your directed graph, where it is, you got writing the directions. Okay, the flow of directions can be mentioned in. For example, 2 to 1 means what? We got writing the 1 to 2 is possible. Also the 2 to 1 also the possible. But another thing is the 2 to 3 is possible, but 3 to 2 is not possible. Also 3 to 1 is not possible. Also 1 to 3 is not possible. Okay, directly not possible. Indirectly you got to possible to 3 means what? 1 to 2 and then 2 to 3. This way you got to reaching at the third position from first position. So verticals, number of vertices. Okay, this is the direct graph. For directed graph means what? There is no directions to be mentioned. But the directed graph means the directions to be mentioned. And the cycle. Cycle means what? Which is we got to the no vertex can be repeated until the first and last vertex are identical. You can look at the figure. It's A, B, C and then again A. Okay, performing as a loop. Okay, that is a cycle. The cycle to be formed. Okay, so it is also one of the features. Another thing is the trees. The tree means what is a collection of nodes can be writing. The normally the tree means what? The root of the tree is we have to consider is the root node, and it has the left subtree and then right subtree. This way the many of the subtrees can be available. Here we got to see the look of the examples is a root, is a T1, T2, T3, T4. These all are, this is a child node of the root node. Here look at the examples, the 10, 20, 30, then 40, 50, 60, 70 and then 80, 90. Here level means what is a 10 we got right, and then next level is the 20 and 30. The next level is the 40, 50, 60 and 70 and 80 and 90. So this is right. Root node means what? the node at the top of the tree is called as the root node because this node there is no parent. Okay, for example, here the 10 is called as the root node. Another thing is the parent node. Okay, those who are having the children, then we got to refer this is the parent node. Here who is the parent node is the 20 and 30 has referred as the parent node. Also 40 also we got to refer as the parent node because the 40 is the parent of 80. Also the 20 is the parent of 40, 50 and 60. Also the 30 is the parent of 70. Okay, this way we got to tell you. Also the 70 is the parent of 90. This way we got to write it. That means the node having the further sub-branches, then we got to refer in there is the parent node. Another thing is the leaf node. The node with no children means we got to refer in there is a leaf node. So for example, here what is there is no children means what are the examples are there? 80, 50, 60 and 90. Okay, this node you got to see that there is no branches are there. Okay, this is the last node. We have to referring this is the child node or leaf node. Another thing is the degree of the node. So normally the flock data in the outcome top to bottom means it is in degree and we got reaching as a root node. Then we got coming from root node to many branches means what that is called as the out degree. That is when the branch is directed towards the node means we got referring this in degree. So when the node away from the node means that is called as the out degree. The degree of the node means what? The total number of the subtrees attached to the node is called as the degree of the node. Here just you got to see that here the 20 is the root node. There is no in degree. Okay, only the 40, 50, 60, the 3 node can be seen away from the node. So it is a out degree only can be available. Then what is the degree of this node? Is it 3. Why we got to set it 3? 40, 50, 60. The 3 nodes are there. So we got to set it. It's the degree of this node is the 3. Okay. Because here the interior of root node is what? This is 0. So that purpose only we got to set it. Which degree of the 20 is the 3. This way I got to write it. Another thing is level and height or depth of the tree. So normally the level of the tree means what? The root can be is always considered as the level 0. Okay, the top of the root node is what? The level is 0 followed by can be incremented by 1. Okay, level of the any node is 1 plus the level of the parent. So for example 10, 20 and 30 is the first level. Then 40, 50, 60 and 70 is the next level. And 80 and 90 is called as the next level. Okay, so this way you got to write. So this is the level. But the height of the tree means what? Just in the reversing order. Okay, so we got to set it what? This is a child node. Can be referring this is the height of the tree is 0. Then the next the parent node of the child node is referred as the height 1. Okay, next part is the height 2. Next thing is the height 4. This way got to refer. This is just as the reverse of the level. Okay, the maximum level is the height of the tree. Both are here which is 0, 1, 2, 3. This way got to refer. In that case what? This is which one? 3, 2, 1 and then 0. This way got to refer in it. Okay, the height of the tree is which one otherwise called as the depth of the tree. How do we got to calculate the height of the tree means what? Which one is the longest part from the node to leaf? Then we have to set it. This is the height of the node. All the leaves are at the height is 0. For example, now we got to consider, look at here. What is the height of this 70? Is a 1 because the 90 is a 1 node is there. Okay, what is the height of the 30? Is a 90, 70 and then 30 is a 2. Okay, the height of the 40 means what? Is a only 1. It's a 80 only that. So it's a 1. Okay, this way you got to write it. That means 80 and 90 we got to set it. The height is 0. And 40, 50, 60, 70 is the height is the 1 and 20 and 30 and the height is the 2 and 10 is the height is the 3. This way got to referring it. This is a level and the height of the tree. And then the siblings. So the node within the same parent, then we got to referring this is called as siblings. So sisters or brothers. Like that we got to writing. Okay, which node can be derived from the same parent. Then we got to set it. These derived childs are called as the siblings. So here the 40, 50 and 60. These three are the siblings of 20. And thing is, what is the binary tree? The binary tree means what? No node have the more than 2 children. Then it is, you got to refer, this is the binary tree. Just you got to see that is a root node means one is the left subtree and then is the right subtree. Only the 2 subtrees can be available. Okay, followed by what? The left subtree. Again we got to classify into mean again 2. The right subtree means again we got to classify into again 2. Okay, this way the 2 node to be developed with each nodes. So what is the complete tree? How do we got to set it? For example, see here 10, 20, 30. Okay, say two nodes, and 20 you got to see as the first 40 and 50, and 30 you got to see as 60 and 70. This way, the each node consists of one is the left child and another is the right child. Okay, this way right. So how do we got to denoting the total number of the nodes means what? Here what is the height of this one? Okay, so 0, 1, 2. Okay, so we got to referring what is the number of leaf can be there means all right. Okay, the total number of the node is what? This is 7. Okay, so we got to write it what? We got to write the total number of node can be present means what? Just as you got to write. For example, now the 2 raised to 2 because the height of the tree is what? 2 raised to 2. 2 raised to 2 means the height is what? Is it 10 is the 0th level. That means 0th height. Then 20 and 30 is the first height and 40, 50, 60, 70 is the second height. So we got to referring 2 raised to h means what? 2 raised to 2. That's a 4. 4 leaves can be present. 40, 50, 60, 70. This is the 4 leaf nodes. And the thing is how to finding the number of nodes means what? 2 raised to h plus 1 minus 1. Here what is the height of this tree? That's h is equal to 2. So we can refer so 2 raised to 2 plus 1 means what? Is 3. 2 raised to 3 means 8. So 8 minus 1 means is a 7. So the total number of nodes can be present in this complete binary tree which is what? Is a 7. Okay, this way right. Another thing is the Abel tree. So normally the Abel tree is otherwise we got to known as is a balanced tree. Okay. So these tree structures we got to retrieval or order of insertion and deletions, everything will base the order in the based on the height of the subtrees. Okay, balanced height of the subtrees can be we got to use. Okay, so how do we go to finding the balanced tree? Okay, normally what is the difference between the height of subtree of in the left subtree minus your right subtree? Okay, then only you got to getting as the balanced subtree. So normally 0, 1 and minus 1. These three are acceptable range. Okay. So other thing is not accepted. So that time it is in unbalanced one. Then you got to balancing it. Okay. Example. Okay. Just you got to go through each. Here what is a balance factor is equal to initially what? This is a 0. Okay. Next one what? Only the left subtree is there. There is no right subtree is there. Okay, so we got to set it as a 1 minus, there is no right side tree is there. So 1 minus 0, this is equal to 1. Okay, now the balance factor is 1. Okay, consider these examples. Here, what is that? The 10, the balance factor is 0. The 6, the balance factor is 0. Why we got to put it 0? Because there is no left subtree and then no right subtree. Okay, the initially all are there is no left subtree and no right subtree means we got reporting as a minus 1. This is minus 1, the here also the minus 1. So minus 1 minus minus 1 means what? We got to getting the values as a 0. Okay, so that case only we got right. The child node the values is 0. Okay, balance factor. Then after that what? 14. 14 means what? Only the right side which left subtree is that. There is no right subtree. So we got writing so 1 minus 0. So we will getting the values is 1. Also, another thing is what? 8. So here we have to finding is the balance factor. How do we have to find? In the left subtree only 1. Which one? Left subtree is that. But right subtree is what? The 2 subtrees is a 14 and then 10. The 2 node is that. Okay, we got to find is a 1 minus 2. But totally we got to getting as the minus 1. Just we got to see as the balance factor range is a 0, 0, 1 and then minus 1. All are available in the which one? In the order. Okay, what is the acceptable range is there? The between the ranges the balance factor is available means we have to set it. This is the Abel tree. But Abel tree means it's a binary tree. It's also the difference between the height of the left subtree and then right subtree. The root is never be more than 1. Okay. Thank you for your patience. Thank you.